Okay, so, we are, Ivan, we are kind of behind on things. And because we have, believe it or not, gone back and taught a lot of Algebra 1 and Algebra 2 again. And it's still not quite clicking, so that's still a problem. And it's unfortunate that this is pre-cal. The quarter ends on the 28th. SATs are on the 19th. And we have a district assessment to fit in, which I believe we currently have it scheduled for the 18th. That is probably going to move because we need to get you more material before then. So today, we have a homework assignment that's on Delta Math that is, can you just use these formulas? I will show you an example of one of the formulas. I have them printed out over here, like after the exit card, entrance card, feedback card, whatever time we get ready for it card. Pick one of these up afterwards. It's for your reference. And this is how the county will give these to you on your district assessment. So I want you to be able to use them. So today, can you take out some notes? We're going to, this is what the mess looks like. Take out your notes. And we are going to practice a little bit. So the county's going to give you this big old mess. Okay? And just want to show you, I don't know, one of them. David, you pick. Sine or cosine? Sine. Okay. So, Kylie, you pick. Plus or minus? Plus. So if I'm asking you to find sine A plus B, which I need to tell you a bunch more information before doing that, but I want you to first see, like, there's nothing easy about this. How do I even find out what the equation is? This is stupid. What the heck? Well, sine A plus B, the plus was on the top. So I'm going to pull this equation off. Sine A cosine B. What symbol should I write? Should I write the plus or should I write the minus? Everybody, what do you think? Plus because that's a plus, or a plus because that's the one that's on top? It's because it's the one on top. Okay, yes?
Are we writing this down?
Yeah. So write down sine A plus B. And Emery, I was gonna ask you, pick a quadrant. 2, 3, or 4?
3.
3. Ahmed? Sine, cosine, or tangent? Which one are we gonna be given? Pick one, just tangent. Okay. I'm gonna say tangent of A is 3 over 4 and it's in quadrant 3. This is all this crappy information I need to give you. Mache, pick a quadrant, 1 through 4. 1, okay. B is in quadrant 1. Oliver, sine or cosine?
Cosine.
Cosine of B is 5 over 13. So I had to tell you all this. And I want to know what sine A plus sine B is. All right. So I have the formula, and your homework tonight is Delta Math. And Delta Math, if it's confusing to you, click on the show solution so it shows you like spelled out how to do all the steps. If you're still confused, click the show video. So I need to know sine of A. Looking at this information, do I know sine of A? No? Okay. What can I do to figure that out? Yeah? Pythagorean theorem. So before doing that, I need to draw the
Oh,
triangle in the correct quadrant. What quadrant is it in? Emery picked 3. So this is angle A. How am I going to label the triangle, Angel? If tangent of A, the triangle's down there, tangent of A is 3 over 4. How am I going to label that?
Put 3 on the top of it. Plus the
So-
other side.
So the 3 goes here.
Yes.
Tangent is opposite.
Oh, okay, it's 4 and then would be negative 3.
Okay, not just -3, but -4 also. So he says, wouldn't it be -3 because it goes down? Yes, it will. And wouldn't it be -4 because we're going to the left? Yes, it will. Emma, what's the hypotenuse going to be? 5. Yep. Pythagorean theorem. Okay. So Alana, looking at the triangle that we've now got drawn and we figured out, why did we draw it where we did? Well, someone said it's in quadrant 3. Somebody said tangent's 3 over 4. So Angel told us how to label it, and we got our Pythagorean theorem for us. So now looking at the triangle, what is sine of A? Opposite over hypotenuse, so what is opposite over hypotenuse? Okay, so sine of A, I am going to replace with this fraction, -3 over 5. And that's a multiply. All right, now I need cosine of B. Do I know cosine of B? It was given to us. Okay, well, that's convenient. Thanks, Oliver. Now I need cosine of A. Look at how am I going to find cosine of A? Yeah. -4 over 5. Why? Because looking at the triangle where we were told to draw it, adjacent over hypotenuse is -4 over 5. So Danny, sine of B. How do I find sine of B? Can I just read it off right away? I gotta make the triangle in what quadrant?
In the first one.
In the first quadrant. Why? Because that's where Masha picked. So there's B. Bella, how am I gonna label the lengths or the lengths of the triangle? If cosine is 5 over 13.
The opposite is 5.
Cosine is adjacent over hypotenuse, so this is the 5 and that's the 13. Doing Pythagorean theorem, does anyone know what that one is without having to do it all?
It's 12.
It's 12. Oh, with authority, it's 12. Okay, but Sophie, now looking at the triangle, because Danny's like, we can't do that yet, we need to know what's going on. So I need sine of B. What is sine of B? 12 over 13. Now it's just arithmetic. So -5 times, or -3 times 5, 5 times 13, -4 times 12, over 5 times 13. It's just arithmetic, it's just a process. Emery, what?
no, I'm just like, that's like a long process if we're like supposed to do multiple.
Okay. So, it's, here are all the formulas that are on that sheet. What you need to do is just use them. So, they will probably give you some hints about, hey, this angle is over here, draw the triangle, label the pieces, Pythagorean theorem, get the other side. And then just process, just read the things off. It's not that hard, it's just, you're right, a little bulky. Emma?
So when you're saying it's like the top, If I do plus, then it would be minus, cause it's like top, bottom, bottom.
Okay, so if David chose cosine, if I said cosine A plus B, well, that's cosine A, cosine B, sine A, sine B. That plus was on top, I'm gonna take the minus that's on top. Third period said, well, how do you prove that? It doesn't help you to see the proof. I use log cosines and Pythagorean theorem, and I do a lot of stuff, and I end up with the formula. I don't see that being helpful, so I just want you guys to be able to use these. And I realize the one example we did is not enough, but that's why this is on Delta Math, for you to go through and practice these skills, and we'll do them more in class tomorrow, okay? But I would like to go over any questions you guys have on the homework that you had, so that you can be more prepared for the exit card. So questions on any of those? Yes? 27. This one, 27, was a bit of a stinker. Okay. So some of last night's homework were definitely a challenge. Okay, first off, both sides look complicated. I'm gonna try and change the left, because I like cosine and sine, so they're more comfortable to me. Pythagorean identity, tangent squared, that's secant squared minus 1. Secant squared minus 1 is difference of perfect squares, so I can factor secant plus 1, secant minus 1. And then, cool, those guys cancel, but then I get secant x minus 1 equals this fraction. Those are two things, two separate things. To take two separate things and add them together as a fraction, I need a common denominator. Well, maybe I need to turn secant into 1 over cosine. Why that? Well, first of all, looking to the other side needs a cosine in the denominator. And I know that secant is 1 over cosine. And then I need to add 1 to it. I can't just do 1/2 plus 1 and get 1/2. 1/2 plus 2 over 2, that would be 3/2. I need a common denominator. So cosine over cosine, I'm multiplying by a sneaky 1. And now that they are in common, I get the left and the right equal. Third period did this very differently. I didn't, like, it worked. It was harder to see. So not saying, like, some of you did things differently and you'd be perfectly correct as well, but harder. Yes.
I like switch tables.
Okay, yep. So third period changed everything to sines and cosines, which was hard. And then was like, oh, I don't like fractions and fractions, so they multiplied everybody by cosine squared over cosine squared, which that cancels. And then you've got to distribute this. Cosine squared times 1 over cosine, cosine squared times 1. Well, and then, as you said, this side only has cosine, so get rid of sine squared using that identity. And looking to the other side, I see that I want just a cosine, so I'm going to factor that out. And then difference of squares. And if this works for you, and if this is the way you saw it, cool, that's the hard way to go. Not that my way was super easy, but yes.
I did like a little bit, I did like, instead of multiplying, I like added 1 to the bottom by doing like cosine x over cosine x.
Okay,
And then, I use that to like cancel out 1 cosine. It's kind of hard to explain without like writing it down.
so here you did,
I did like the same thing with like changing it to sine and cosine and 1 over cosine. Yeah, like that.
and tangent squared is up top?
Yeah, I mean, I changed that to like sine over cosine, but yeah.
Okay, and then what?
Then I like, I'm trying to see. I think I like canceled the, wait, I don't know what I did. I'm like trying to figure it out. Not sure what my next step was.
Okay. Well, I mean, it's looking kind of like what we have here. Because you found the common denominator at the bottom so you could squish them. So it's
Yeah.
this guy divided by that guy, divided by a fraction, it's multiplying by the reciprocal, those guys cancel. So I end up here.
Yeah.
So here, you're still gonna have to get rid of that sine squared somehow, and I think really the only way to do that is this stuff, like, it should be similar to what we've got here, and
Can't
it,
you change sine squared to 1 minus cosine?
yeah, right here, that's what I said.
Oh, but it's 1 minus cosine squared and not 1
Correct.
minus cosine.
There you go. Yes,
Okay.
okay. All right, other of these, yeah. I love 38. It's stealthy simple. So, looking on the right side, I got some cosines. I like cosines, so, and I know secant is 1 over cosine, so maybe on the right-hand side, or, yeah, right-hand side, I'm gonna turn secant into 1 over cosine, and I'm just gonna multiply the top and bottom by a sneaky 1 of cosine over cosine. Distributing to everybody. Stuff cancels, and I, in one step, get the other side. One step.
So you just multiply by cosine?
Cosine over cosine. I multiplied by 1. Right? I'm allowed to multiply by 1. It changes the look, but not the value. Okay. Alana?
Why did you put cosine x plus cosine x, like why did?
Okay, here, my first step is this. Then I'm multiplying cosine to the top and the bottom. Cosine times secant, well, secant is 1 over cosine, and this cosine gets multiplied to there. And then cosine times 1 is this guy. And again, 1 over cosine times cosine, and cosine times 1. And careful, at least one person in 3rd period said, Luca, cosine over cosine canceled out to be 0. Stuff over stuff, exactly the same stuff, that reduces to be 1. If I had 5 things to share among 5 people, everybody gets 1 thing. If we're splitting it equally. Question? All right, can you put stuff away? I didn't get them printed on a separate sheet, so there is formulas.